Alright, sorry about that. I had to delete a few things off my phone. And so we solve for A, B, and C. You can say 2C minus 1 is equal to 0, so C equals to 1/2. And what's going to happen is now that I have A, B, and C, I'm going to plug them back into my formula where A is over S plus 2, or A times S plus 2. And so I'm going to have negative 1/4 times 1 over S plus 2. My B is 1/4, so multiply that by S over S squared plus 4, because it was BS, so there's the S, and then it's going to be C on top, so it's going to be 1. Now, C was 1/2, but I noticed S squared plus 4 and just, a constant on top, well, that looks a lot like sine. And so, because it looks a lot like sine, I would need a K on top. Well, it looks like my K would be 2 because 2 squared is 4, so I'm going to go ahead and put a 2 there. In order to take that 2 out, instead of having a 1/2 for C, I'm going to go ahead and make that 1/4. That makes my work a lot easier if I can notice that right off the bat. So I did. And that way it's easier to change. So I'm going to pull out all the coefficients, and I'm going to take the Laplace transform of 1 over S plus 2. Well, the Laplace transform of 1 over S plus 2 is going to be e to the negative 2t, so that's times negative 1/4. The Laplace transform of S over S squared plus 4, I noticed, hey, that's cosine with 2 as my K, so it's going to be 1/4 cosine of 2t, and I noticed that this is also the sine, and so it's going to be sine of 2t times 1/4. And I could pull a 1/4 all out and write that, all together in one line. I'll just keep it this way to save some time. All right, now, the last thing is transform of derivatives. And what we want to do here is we want to, basically write out what all the Laplace transforms would be for differential equations. So that, if I have the Laplace transform of a derivative or the second derivative, I'm able to go right straight to these solutions. And so, now if I'm doing a Laplace transform of the derivative of f, then I'm going to do the same thing. I'm going to write it in my integral from 0 to infinity. I'm going to use my kernel, e to the negative st, times whatever is on the inside, which is the derivative. All right, well, I'm going to do integration by parts to solve this. If I do integration by parts to solve this, the part that would be my u, I would make e to negative st. And the part for dv would be obvious because there's the derivative, f prime of t. And so my v would just be f of t. Derivative of e to negative st is negative se to negative st dt. And so now I'm going to multiply the u times v and get e to negative st f of t from 0 to infinity. And then I'm going to have the integral of my v times my du, which I'm going to pull out that negative s to make it plus x, the integral from 0 to infinity, e to negative st times f of t dt. Now, this part over here, if I plug in infinity, this is going to give me 0. So this, when I plug in infinity, that part's going to give me 0. Minus, plug in 0 for t, that's going to be e to the 0, so 1, and then f of 0. So it's going to be negative f of 0 for this part. And then for the back part, when I look at this and look at the integral, well, this right here is just the Laplace form of f of t. And so then I can say, well, negative f of 0 plus s times the Laplace of f of t is my solution. So the Laplace of f prime of t is equal to, since the Laplace of f of t is just cap f of s, this is s times cap f of s minus f of 0. And the same thing is going to be true for f double prime of t. If I do f double prime of t, I'm going to go ahead and do integration by parts, where of course the f double prime is the dv, the u is e to the negative st, I get, du as negative se to negative st dt. My v is just the integral of the derivative, or the integration of that, which is f prime of t. And so then I get u times v is e to negative st times f prime of t. Plug in the infinity again, 0. Plug in 0, this is going to be 1 f prime of 0. So I have negative f prime of 0 plus s times the integral from 0 to infinity e to negative st f prime of t dt. Well, I already know what this is right here. This is just that. And so it's s times Laplace of f prime of t, which is s times s f of s minus f of 0. So this part is this, so times s minus f prime of 0. Distribute the s squared, cap f of s minus f s of f of 0 minus f prime of 0. And so this is what I'm going to be substituting in for. And I'm just going to do the top part for page 7. The Laplace of f double prime of t, f triple prime of t is equal to, and it's going to have the same type of form, s cubed f of s minus s squared f of 0 minus s f prime of 0 minus f double prime of 0. And if I did, Laplace of derivative to the 4th degree, and be s to the 4th f of s minus s cubed f of 0. It'd take that same form as well.